So the next question that we have involves drawing graphs. We have been given 4 moles of a monoatomic gas with a pressure of 3 into 10 raised to 5 pascals and T is equal to 100 Kelvin initially. This is called state A. From state A, it undergoes an isobaric process to T is equal to 400 Kelvin. This is state B. Then it undergoes isothermal expansion to a pressure of 10 raised to 5 pascals. This is state C. And then it is cooled isobarically to 100 Kelvin, state D. And then it is compressed isothermally back to the state A. So we need to draw the PV, PT and VT diagrams qualitatively. So let us first draw the PV diagram. Let us see what the PV diagram looks like. The initial state was state A. Let this be pressure P. Let us call it PA and VA. This is TA. So PA. Now it undergoes isobaric process to temperature is equal to 400 Kelvin. This was 100 Kelvin. Now it undergoes an isobaric process, so it has to be along this line. But since the temperature is increasing, we know that the isotherms lie in this fashion. These are the isotherms for a PV curve, and this on going upwards, the temperature on the isotherms increases. Therefore, we have to go this side. So this must be state B. This is state B. This is state A. Isobarically to state B with a temperature of 400 Kelvin. Now it undergoes isothermal expansion to a pressure of 10 raised to 5 pascals. This was 3 into 10 raised to 5 pascals. Now we come down to 10 raised to 5 pascals. This will be somewhere around here at this point. So this must be the process. Why? Because it is an isothermal process, so it should lie along an isotherm. It should lie along an isotherm, and the pressure comes down and the volume increases. Therefore, you increase the volume. Now it is cooled isobarically to 100 Kelvin. Now again it is isobaric. It is cooled, therefore the temperature should decrease. Therefore we come down from C to D to 100 Kelvin again. This was 100 Kelvin. So we again land up to this point itself, which lied on the isotherm involving the point A. Therefore this is the point D. Now we have isothermally compressed it back to state A. Therefore it has to be this isotherm because it is an isothermal process. So a total process is, we start from A, go to B, then C, D and then A. So this is what the PV diagram looks like. Now for the second part, let us draw the PT diagram. For a PT diagram, so this is how you should catch all the hints to make the graph. Now in a PT diagram, let us again start from the initial state, that was state A. Let this be state A. The pressure was 3 into 10 raised to 5 pascals. This was 3, this was 1, 2 in 10 raised to 5 pascals. Let this be 3 into 10 raised to 5 pascals, 3 units on this side. The temperature was 100 Kelvin. Let this be 100 Kelvin temperature in Kelvin. Over here in 10 raised to 5 pascals. Now it undergoes an isobaric process to a temperature of 400 Kelvin. Now since the process is isobaric, the pressure is constant and the temperature increases, so it simply is a constant pressure process with going to temperature of 400 Kelvin. Therefore this is point B. It goes from A to B. Now it is cooled isobarically to state D. Therefore it is again there is an isothermal expansion to pressure 10 raised to 5 pascals. Therefore the pressure reduces. It comes down to this point C, and since it is a isothermal process, therefore the temperature is constant along this line. Now it is cooled isobarically, so constant pressure, the temperature reduces to 100 Kelvin. So it can be this path only because it is constant pressure and temperature reduces to 100 Kelvin. This is your state D. Now we cool it isothermally back to state, no, not cool it, we bring it isothermally back to state A. So this is an isothermal process which can bring it to state A, since both D and A are at the same temperature. So final PT graph looks like this. Now we need to draw the VT graph, that is volume versus temperature graph for the gas. Now when we draw the volume versus temperature graph, this is the most interesting graph which we'll draw now. The initial pressure was 3 into 10 to the 5 pascals and temperature was 100 Kelvin. Let this be 100 Kelvin temperature and let this be pressure of, let this point be A. This denotes a pressure of 3 into 10 to the 5 pascals. Now it is taken by an isobaric process to a temperature of 400 Kelvin. Now isobaric process is a constant pressure process. If we write PV is equal to nRT, V is equal to nR upon P into T. So if the pressure is constant, the slope of the VT curve will be constant, that is VT curve will be a straight line passing through the origin. If we get the equation in the form of y is equal to kx, then this is a straight line passing through the origin. Therefore the VT graph will be a straight line passing through the origin. Therefore it expands to a temperature of, or rises to a temperature of 400 Kelvin. This is a straight line. So this is point B. The temperature at this point is 400 Kelvin. Now it undergoes isothermal expansion to a pressure of 10 raised to 5 pascals. The pressure initially was 3 into 10 raised to 5 pascals. The pressure is reducing. Now we know that if the pressure will increase, now from point B it undergoes an isothermal expansion to a pressure of 10 raised to 5 pascals. The pressure at this point was 3 into 10 raised to 5 pascals. This line, this straight line passing through the origin, this is a straight line through the origin. This represents a constant pressure of 3 into 10 raised to 5 pascals. It reduces to this pressure, that means the pressure reduces, the temperature is constant, P is equal to nRT. Now the pressure reduces, the temperature is constant, therefore the right hand side is constant, therefore the volume must increase. Therefore the volume increases under constant temperature to a point such that the final pressure is 10 raised to 5 pascals. This is point C. Pressure is equal to 10 raised to 5 pascals. Right? Now from point C it is cooled isobarically to 100 Kelvin, that is state D. Now since it is again a isobaric process, therefore it will again be a straight line passing through the origin. Therefore it will be a straight line passing through the origin joining point C and the origin. Therefore the point D will be a point at a temperature of 100 Kelvin. The point therefore must lie over here, 100 Kelvin and the intersection of this process line. Therefore the point D, this comes out to be the point D over here. Now it is again isothermally compressed to state A. So isothermal and compression, that means it comes back to point A from D. So the final VT curve looks like this, the final PT curve looks like this, and the final PV curve looks like this.